This video is for the RLC Lab, Circuit 1. We will need an oscilloscope and a function generator. We will also need a decade resistor box, a decade inductor box, and a decade capacitor box. We will be using banana cables, so we will need to install the BNC to binding post adapter. Two of the three setups are going to require us to give the function generator and the oscilloscope a separate ground, so we use the 3 to 2 prong adapter on the function generator to give it a separate ground than the oscilloscope. Then when the one setup where we want them to have the same ground, we'll do that with a cable between them. We're going to set up the following LRC circuit. We're going to put the ground at the point A and measure all of our voltages from that point. First, we will connect the black post on the function generator to the right side of the resistor. So I plug into the black post on the function generator, and I plug into the right side of the resistor. Now we're going to connect the left side of the resistor to the right side of the inductor. Connecting the left side of the resistor, which is actually the middle plug on the resistor, to the right side of the inductor. Now we connect the left side of the inductor to the right side of the capacitor. Here we connect the left side of the inductor to the right side of the capacitor. And we complete the circuit by connecting the left side of the capacitor to the red post on the function generator. Connecting the left side of the capacitor to the red post on the function generator. In this circuit, the function generator and the oscilloscope have the same ground. So I'm going to have to connect a wire that gives them that same ground. Connecting a wire to the black post on the function generator and the other end to one of the black posts on the oscilloscope. We want to measure the voltage across the function generator from point A to point E. To do this, we are going to connect the red post on the function generator to the oscilloscope channel 1. Connecting the red post on the function generator to the red post on channel 1 of the oscilloscope. We wish to read the voltage across the resistor from point A. We will do that by connecting channel 2 on the oscilloscope to the left side of the resistor, or point B on the diagram. Connecting the left side of the resistor, which is the middle post on the resistor box, to the red post on channel 2 of the oscilloscope. Our circuit is now set up, and we are ready to turn on the oscilloscope. Set the resistor to 100 ohms, the inductor to 90 millihenry, and the capacitor to 1 microfarad. Select the default setup button. Turn on the function generator. Set the function generator to 300 to 500 Hertz sine wave and adjust the oscilloscope to display nicely a few wavelengths of the input wave on channel 1. Move this wave to the top half of the oscilloscope. You can push the measure button and it will display the frequency and peak-to-peak voltage of channel 1. Turn on channel 2. Adjust channel 2 similarly to channel 1 and move it to the bottom half of the screen. Select measure again. Choose source 2. Scroll to get peak-to-peak voltage and scroll to get frequency. Each time after you find what you're looking for, in this case peak-to-peak voltage, push the add measure button. And now you will have the frequency and peak-to-peak voltage for channel 2 also displayed. Adjust to a lower frequency and look at how the phase difference, where the peaks are, differs between the resistor and the function generator. Adjust the function generator to a higher frequency. At some point you get to a point where you see the two peaks lined up. That's at or around the natural frequency. I have to switch to a higher scale on this thing, but continue to adjust upward. Adjust to a frequency that's much higher than the natural frequency. Change the scaling. Notice now that the voltage on the resistor is peaking on the other side of the voltage from the function generator. So we want to adjust the ground for channel 1. You look over here, you see the ground symbol. We want to adjust it to a convenient line for reading from. There, I've got it adjusted across here so I know where the average is, and I do the same thing for channel 2. You may want to adjust channel 2 a little higher to make measurements easier. So here I'm adjusting the ground for channel 2 to a convenient level. Adjust the wave horizontally so that the orange triangle at the top is centered in the middle of the screen. Also make sure that the trigger is at the same level as the ground for channel 1 so that it crosses the ground right in the center of the screen. Notice that channel 2 doesn't cross at the same spot, and we want to know what the time difference is, so we're going to stretch out the signal to fill the screen as far as possible. Here's where channel 2 crosses the ground, and there's where channel 1 crosses the ground. I'm going to turn the horizontal adjust knob until channel 2 crosses the ground right in the center of the screen. If you look, the little orange triangle has moved. It points to where the wave crosses the ground. If you look right there on the screen, gives the time between when the two different waves cross their grounds. This time relates to the phase difference between the two waves. The lab will tell you how to take this time and turn it into a phase difference.